Hi, this is week 4, lessons 1 and 2 video. We're going to be discussing vectors and polar coordinates. So to start with, let's just go ahead and do what we normally do and go down the instructions. So the first one, what is a vector? A vector is a line that has both magnitude and direction. So in a way, it's actually a line segment that has a direction and a set length. So you have multiple ways that you can write a vector. You can write it by delta in the form of delta x and delta y, which is the change in x and the change in y from start point to terminal point. You can write it utilizing the magnitude and the direction, and the magnitude would be your r. So you'd have your magnitude would be your first coordinate, and then you'd have the angle, and that would be the direction from the positive x-axis going counterclockwise. What's the angle of degrees from there? So that's what you'd have there. Adding vectors is fairly simple, especially if you have it in utilizing x and y. For the pieces, you literally just add the x's, you add the y's, and that gives you the new vector, the resultant vector. Multiplication is subtraction is the same as addition. Multiplication is even the same. If I'm going to multiply a vector by 4, I'm going to multiply the x by 4, I'm going to multiply the y by 4, and it's just going to lengthen the line by a factor of 4. I did not remember to read up on the dot product and did not remember seeing it in any of the materials, so I will make sure to go back and do that. The angle between two vectors is fairly simple. If you have, no matter how you have it written, because you have different formulas that you can utilize to find the angles and so forth, that it would be from the standard x plane. So you would be able to go ahead and find what the angle theta for both vectors is, and then you can take the difference between them, telling you how much of an angle between the two vectors there is. Now, polar coordinates. So polar coordinates are written in basically a r and theta, or the so normally you'd have it's your magnitude and your angle. Sometimes all you're given is a magnitude, and it creates a polar circle. And you have your little toolboxes and stuff like that to convert between polar and Cartesian, such as r squared equals x squared plus y squared, your Pythagorean theorem. Tangent theta equaling y over x, which is from SOHCAHTOA. Your tangent equaling opposite over adjacent. Y equaling r sine of theta, x equaling r cosine of theta. These 4 pieces will allow you to convert any direction you need to with any equation or any coordinates given to you, because of how they work. So that covered 2 and 3, I hope. So given 2 vectors, how would you find the resultant vector? So I took this to mean that basically what we want to find is we want to find the vector that kind of points through the middle of the 2 vectors given. And so, I mean, the best way for me to do this is draw a vector along the y-axis, draw a vector along the x-axis. You have a magnitude, you have a direction, and the resultant vector is going to go ahead and be those x and y coordinates. You can convert them to polar coordinates if you choose, and you can also find what the angle and the direction is going to be with the x and the y that you're given. So that's how I would find it. So say I have a one vector that, I mean, just to make it simple, because no, I just lost my train of thought. So you just take it from say, you know, the one vector is 0, 4 along the y-axis, so it goes up 4, and then the other one is 5, 0. So we know that the terminal point of the resultant vector, because we're going to just add them together, is 5, 4. And with that, utilizing our information, we can figure out what both the direction and the magnitude is. If I were given vectors utilizing polar coordinates, say 4, 50 degrees, utilizing my toolbox, I can go ahead and I can, you take the different, you add the 2 degrees together, and you have it, and that gives you what your direction of the resultant vector is going to be. And then with the r's, you can go ahead and you can figure out what the magnitude of the resultant vector is. So that's that. And to do the stump, again, it says that they're 65 degrees from each other. To make it easy for me, I just put the 300-pound force along the x-axis. I went 65 degrees to the 200 pounds, which I just say, the magnitude is 200, utilizing both those. So I have a direction of 0 for the first one with a magnitude of 300, and then I have a direction of 65 with a magnitude of 200 for the second one. And so again, we can go ahead and we can utilize our resultant and find your x and your y points. From the information that you're given, and go ahead and factor it up, and you end up with approximately 425 pounds of force. So you end up with the resultant force, and then from there you can figure out your different angles. So if you're talking from the resultant to the 300 pounds force, you're talking at 25.24 degrees, and to your 200-pound force, you're talking 39.76 roughly. So that takes care of number 2. So this next part is fairly simple to me. It runs through this other one, and I thought it was a really good one, even though overly simple. And so for me, for A, we're going to convert it to polar coordinates. So y equals 3x minus 2. And since we're going to do polar coordinates, we're going to replace y with r sine of theta, and we're going to replace x with r cosine of theta. And so since we want to go ahead and get that on both sides, we want to get r by itself, since we want it to be r's in function form, so basically r theta type form. We're going to go ahead and we will subtract the 3r cosine of theta over to be with the y, so that we have all thetas on one side. And then we know that we can extract an r from that. And so we have r times sine theta minus 3 cosine theta equals -2. Divide both sides by sine theta minus 3 cosine theta, and you get r is equal to -2 divided by sine theta minus 3 cosine theta. And that's that. So the next one is even easier. X squared plus y squared. We have a formula. R squared equals x squared plus y squared. So we know right off the bat that 9 is equal to r squared. Take the square root of it. R equals plus or minus 3. Most of the time it's just going to be plus 3 because it's going to be the radius of a circle. So the next one, we take r equals 3 over 1 cosine theta, and we go, and we're going to go to xy. We're going to go to Cartesian coordinates. With Cartesian coordinates, we're going to go ahead and we're going to want to get it in. We're going to want to find something that gives us a form that will allow us to utilize our toolbox. And so the thing that popped out in my head almost immediately was being able to, I wanted an R with the cosine theta, and may or may not be the right way to go about it. But I multiplied both sides by the 1 minus cosine theta, and then I distributed the r throughout. Trying to find my notes. Give me 1 second. So it gave me r minus r cosine theta, allowing me to turn I'm totally blanking on what I'm doing now. Sorry, no, that's not what I did. Okay. So I know that I can convert oh, I am not understanding my notes now. I'm not sure how I did that last one. So give me 1 second and we will work through it right here. So I multiplied it over and I got r minus r cosine theta. I changed it to r minus x equals 3. R minus x equals 3. And I believe and then I went ahead and I took the r, and since r is equal to the square root of x squared plus y squared, so I had the square root of x squared plus y squared minus x equals 3. And then so that I could get x or y on both sides, I took the x, I minused it over, oh, my handwriting is horrible. So I added x to both sides, so I have x plus 3 equals the square root of x squared plus y squared. Then I proceeded to square both sides to get rid of the square root, which gives you x squared plus 6x plus 9 equals x squared plus y squared. And then from there, you subtract the x squared, leaving you with y squared equals x plus 9, or 3x plus 9, sorry, 6x plus 9. Um, six x plus 9. So, and then if you subtract the 9, so trying to get x by itself, subtract the 9, you get y squared minus 9 equals 6x. Divide by 6 on both sides, you get y squared divided by 6 minus 9 over 6, which simplifies to 3 halves. So your final answer is x equals y squared over x minus 3 halves, or 3 over 2. And so that was that. And yeah. So this one took me a while to go through. I realized that I'd forgotten a lot of this. But the toolbox and the Khan Academy videos were extremely helpful. So here it is.